Namaskar, my dear friends. So we have talked about microcontroller from Microchip technology. We were talking about PIC18F877A. What are the device details and what is its features and where it is being utilized generally. So this is most popular for robust application designs and it is very useful in our engineering academic curriculum. As we already know that there are newer device that is available like PIC16F18877 as well as PIC18F47Q10 pin to pin compatible with our PIC18F877A. Okay, so the thing is in this tutorial what we will be doing is how we can design the complete schematic and what are the different peripherals that we can utilize for. Okay, so let us move. We have already seen this is the particular microcontroller that we have already talked about and what is its design, device details, features and everything, right? You can see we have 28 pins that we are not right now talking about. The device details as well as the schematic design will be same, whatever I am going to teach you just now, which we will be taking for 40 pins. Okay, same way we will be seeing 44 pin as well. So this also we will not talk about right now. Our main target device is this one, which is 40 pin PD package. Okay, so this is the package that you can see. This is most sturdy, very strong device, physically as well as it has a lot of good features as well. However, this particular device is very old and this is not recommended for new design, but for your learning purpose and if you are uh, trying to dive into the microcontroller schematic design, this is the best one to start with. Okay, so what is the minimum schematic that will be needed and how we go for design approach for the schematic, that all we will talk about. Okay, so let me point out what are the different peripherals or different circuits that we'll be designing in this. So first of all we'll be seeing what is the power supply, how we can design it, what will be the programming techniques, what are the reset switches and all. We'll put some user push buttons, dip switches, LEDs for our normal applications. We'll be giving I2C application like I2C application or inter-integrated circuit applications. We have SPI, UART. So all these peripherals we'll talk about. We have parallel slave port data communication. Okay, we have LCD interface, we have timers, we have PWM. So all these parameters we'll try to see. So we have already seen this is our pin to pin, pin descriptions or pin out of the particular device, and these are the things that we will be seeing in the particular session, right? We have already seen the pin descriptions in our previous videos, so that I'm not going to talk about right now. You can already see that the pin descriptions and what are the pins, how it can be utilized for. You can see RB0 can be used as interrupt and all those things that we have seen already, right? So let us talk about next directly. Okay, so we are ready to proceed for our circuit design. This is the PD package 40 pin that we have talked about. Please make a note of PIC16F877A-I/P. This is the device we will be designing right now. Okay, so very first thing that we need to do is, this is our power pins VDD and VSS, VDD and VSS. So we require power for this and we know the power for this requirement is 5 volt. So our first aim is to design the power and then we'll go ahead with reset switch. This is our reset pin, and then we will be talking about programming as well. So programming is PGD, PGC and PGM that we have already discussed in our previous videos, right? So when we talk about power, first of all we have to understand that how we will be taking power from outside. So let us say we have a 2-pin connector here. So I have given a 2-pin terminal here. So it will be taking a power from 9 volt to 12 volt. Okay, if you want you can reduce a little bit also, like close to 6 volt also you can give, but it will be a bit tough. So I suggest you to give from 9 volt to 12 volt. Okay, and this is the diode that will be protecting for any damage or something like that, or like back fire. So this is the reason I have given one diode. This is around 2 ampere rating. Okay, One of the most like popular series linear regulator is LM7805. So 05 is actually 5 volt series, and this is TO220 package. Okay, if you want, you can utilize other linear regulators also. So let me give you the part numbers for you. That will be LM340 80-5.0 slash NOPB. Okay, so this is also very popular and very equivalent, pin to pin equivalent of this and this both. So LM34080-5.0 as well as LM7805 CT slash NOPB. Okay, if you want, you can utilize so many other regulators are also there, so nothing to worry about. Okay, so this is our bulk capacitor, which will be 220 microfarad. I'll be taking 220 microfarad slash 35 volt. If you want, you can go ahead with 63 volt as well, but I'll request you to keep minimum 35 volt. Okay, this is our filter capacitor kind of thing. So zero point 0.1 volt slash 25 volt or 50 volt, you can take, very popularly available. Okay, this is a 47 microfarad capacitor. I'll be asking you to keep it again 35 volt, or if you want, you can keep as high as possible like 63 volt. But the price doesn't matter, then you can keep 63 volt, otherwise 35 volt is good. Okay, I have kept ceramic capacitors 10 microfarad and zero point 0.1 microfarad. Okay, so since it is 5 volt, I'll request you to keep minimum 16 volt or 25 volt, and this one you can easily keep it 25 volt or 50 volt. Okay, so this is how we have designed the complete power supply. One more thing, I have given a provision here, jack. Okay, so there are jacks that is available. So if you have a adapter, so adapters are generally, like 6 volt adapters or 12 volt adapters or 9 volt adapters of around, like 1.5 ampere or 2 ampere or even 3 ampere up to, I will suggest you to keep. Okay, so this is the way we have completed our design for power supply. So power supply requirement was what? Give you you give a power supply from your DC power supply or a power adapters through the jack. Okay, and this is the regulator which is going to convert this input power to the output power, output voltage as 5 volt. Okay. If you require on the board, like I have kept a provision for VDD, this is 5 volt, which is going to get converted to 3.3 volt as well. So if there will be any requirement for 3.3 volt application in our schematic, this particular voltage will be utilized. And this is a very good LDO, which is TPS7A20 series, and this is 300 milliampere capability. And this 5 volt power supply was 1.5 ampere capability. Okay. So once we are ready with our power supply, now we are very much ready to go ahead. Let us talk about the the pin output of our microcontroller. So this is our PIC16F877A-I/P microcontroller. I have kept a pin as it is 1 to 20 and another 21 to 40. Okay, so I have not changed the pin like arrangements or something like that. Now very first thing what we will do is we'll try to concentrate where is my VDD pin. So this is VDD1 and VDD2, and this is VDD2, and this is VSS1 and VSS2. So this is power supply and ground pins. So I have kept a decoupling capacitor. This is called decoupling. So decoupling capacitors are actually needed. So you give your power supply with your decoupling capacitors. So that is more than enough. So your power supply is ready. Your device is ready to proceed. Okay. Another important thing is we have a MCLR pin, which is the reset pin, so that must be pulled up. Okay, so it has to be pulled up with 10K or little bit less, so I have pulled it with 10K. If you want to reset your device, then you have to give a switch. So I will give you the part number for this particular switch as well. So this is from Worth Electronics. Okay, so once you press this particular switch, what will happen? This will get grounded, and this pin will get grounded, and it will get reset. Okay, this 0.1 microfarad, okay, or if you want you can reduce it to 10 nanofarad as well, okay. So you can give it to ground. Suppose you don't want to ground it, or during like programming it is not working, what you can do is you can demount it or do not use it, okay. Or if you want to have a provision, you can keep a jumper in the middle, so it will be easier for you to remove the jumper and put the jumper, okay. But this will work as it is. Now we have completed our power supply, then we have completed our reset. Now we'll talk about programming, okay. Programming. So programming pin, as you can see, we have PGD pin, PGC pin and PGM pin, okay. Newer microcontrollers are not having PGM pins, so only 2 pins are more than enough, which is ICSP programming it is called as, but it is PG programming. So if you see PIC Kit 3 programmers, then you will see this is a 6 pin connector. You can see the part number as well. So it is 2.5 mm pitch part number. So you have MCLR pin and you have 5-volt input. If you want, you can keep VDD, or otherwise 5-volt I have kept by keeping a small resistor here, like 0 ohm resistor, and this is my VDD pin and this is my 5-volt that you will see in our next slides, okay. So this is how it will look like, okay. So you can change the net names like that. So this is my 5-volt, which is my supply, okay. And this is my MCLR pin, which is reset. This is my ground one, and this is your PGD and PGC and PGM, okay. So just direct connection, you don't have to pull up or pull down or anything, you don't have to do anything. uh, this is very robust, very easy to design the programming. So programming is complete. You can directly connect these lines to the microcontroller pins and it is ready to proceed. Now we have one pin in this particular microcontroller which is open drain pin. So if you want to use that pin as a like output pin or output pin, then you have to pull it up, okay. So this particular pin has been pulled up to 10 kilo ohm. So this is the only pin that is available in this particular microcontroller, which is open drain, okay. So open drain pin must be pulled up. If you want, you can reduce the value by to like 4.7K as well, but I'll recommend you to keep it 10 kilo. Next, I have kept one RA5. You can see RA5 is here, okay. So this RA5 is going to come here, and with there is VDD pin, which is like 5-volt. So 5-volt, what I'm going to do is, this is a potentiometer 10 kilo ohm, and based on the resistance variation, there will be a voltage that will be generated here, let's say Vx, and this Vx will be appearing at RA5, and it will be taking as my analog input, okay. So that will be ADC. So a simple ADC design, if you want to do based on the variation of your potentiometer, you will be able to find out what is the value of your Vx, okay. So this is very easy to implement, and you can like check in your circuit what is your ADC values. Got it? Rest others, all pin names and numbers I have written it. What I'll do is, in the next slides I'll like I'll take up one by one. So let us talk about first oscillator. We need frequency input also, like we need clock for this particular microcontroller. So what we shall do, what we'll have to do is, right now I have taken a 12 megahertz crystal oscillator. You can take up to 20 megahertz maximum, okay. So up to 20 megahertz crystal oscillator you can utilize. I have taken a part number which is very low cost and very sturdy. So this is LFXTL 033580, okay. And you can see 18 picofarad, 18 picofarad if you keep, and oscillator 1 and oscillator 2 if you add, as shown in the circuit here, oscillator 1 and oscillator 2. So your clock requirement is also complete, okay. So hope you are like able to follow. Like we have completed our power supply, programming, open drain pins configuration is also done. We have a simple ADC configuration. Then we have put our oscillation pin as well. Rest other pins we will see one by one. So proceeding to next, we have completed our oscillator. Very simple, like if you want to understand how a microcontroller can work off, then you try to give one like a push buttons, okay. So what I have done is I have given the power supply here 5-volt. this 5 volt is going to go and get connected to user PB0. So user PB0 is coming here, and through 0 ohm it is going to RB0 pin. So if you see RB0 pin, which is here, RB1 pin is here, so it is going to connect here. So I will not be showing again and again. For the first time I have showed it to you. Okay, so user PB0 is actually seeing high. Okay, now whenever there will be a user which will be pressing this particular switch, what will happen? This particular pin will be pulled low because it will get shorted. Okay, so it will be pulled low, and the user PB0 pin will go to PRB0 and it will show a low. So this is how microcontroller will come to know that the button has been pressed, and based on this button press you will take some action. Okay, same way I have given one more user button for this particular schematic. Okay, so this is how you can interface your push buttons. Okay, next there are deep switches that is like available. So I have given you 4 deep switches in this. So what is happening here is this is 5 volt, and these are the deep switch 0 1 2 3. So you can see deep switch 0 1 2 3 and going to go to your microcontroller pin RD0 1 2 and 3. Okay, so right now what it is seeing is, suppose if it is not connected, okay, then what will happen? 5 volt will not be appearing, so it will be having actually 0. So this is pulled down. So all these deep switches will be on 0 0 0 state. Okay, now suppose you want to slide this switch to 1. So this 5 volt will actually appear here, and this 5 volt will go to RD0, and it means it is telling you that it has been like become high. So this deep switch is very useful to change the state of your any pin. Okay, so this is how it is very useful. So deep switches and push buttons, we have understood how we can interface to the microcontroller. Got it? If you want, you can connect directly to the deep switches to the microcontroller pins, but to avoid any confusion, or like if you want to remove it and use it for other purposes, I have given a resistance in the middle. So this resistance can be removed, and this particular pin can be utilized for other purpose as well. Got it? Now the most useful items in our like a circuit design is keeping user LEDs, so that you can like glow the LEDs and understand what is happening. Okay, so there are 3 methods that I have utilized here. One is directly give the 5 volt power supply. Okay, so power supply is here. Through the resistance it is going to LED, and it is going to the user LED 0 pin. So user LED 0, you can see it is going to RD4 through the user LED 0 and a 0 ohm resistance. Okay, now what will happen whenever the microcontroller pin becomes low? Then this will get sorted and the LED will glow. Okay, and if you want to like switch it off, then you have to make it high. So if user LED pin, that is your RD0 pin, which is going to be go high, then the LED will not glow, and when it is going to low, then it will glow. Got it? So same manner you can use for your user LED 1. So this is how you interface your LEDs to a microcontroller pin. Are you guys getting it? Good. Let us proceed another method. Suppose you don't want to work through the microcontroller way, then what you can do is you can directly connect to the microcontroller pin like user LED2 and user LED3 I have given. So user LED2, LED3, which is going to RD6 and RD7. Got it? So whenever this will go high, what will happen? This LED will get power and it will glow. So whenever it is high, it will glow. Whenever it is low, it will not glow. Got it? Same way, user LED 3. Understood? And based on your requirement, I'll give you the part number for all the LEDs. Same LEDs I have used. But if you want to use different colors LED like red LED or green LED or blue LED or yellow LED or amber LED, any color LED if you want to utilize, if you want to find out a part number for particular LEDs that you want to know, you can put down your comments or your queries in the comment box, and I shall give you the exact part numbers for your application. There are a lot of LEDs that is available in abundance through like light switches, and and Worth Electronics. Okay, so Worth Electronics I prefer a lot. So you can have any number of like LEDs or any varieties of LEDs that you want to find out. Worth Electronics will be your best choice, as well as for push buttons as well as deep switches. Okay, so push button, deep switches and LEDs, Worth Electronics you can try out. And if you want to understand how to select a part number from Worth Electronics, I'll give you a separate tutorial as well for any of the components that you are looking for. Let us proceed to the next method of your like glowing your LED. So suppose you need you need to glow your LED in another method. So what happens is, this is my power. It is connected to the LED through a resistor, and it is going to a MOSFET. Okay, so this is my drain, this is my gate, and this is my source. So what happens whenever this user LED 5, which it is connected to RE1, got it? So if you see, whenever RE1 goes high, then this gate will get enabled and this drain to source will get sorted, and this is how the circuit will complete and it will start glowing. Got it? So if you want to glow your LED D5, or what is this, D8, right? So this is D8 LED. So D8 LED, if you want to glow, your RE1 should be high so that gate gets enabled, and you have to you will get your LED glowing. Okay, suppose you want to disable the LEDs, this pin has to go low, and this is how the gate will get 0, and this will get disabled. Okay, so LED will not glow. So same way D7 LED will also glow, which is your user LED 4. Okay, through your RE0. Got it? So this RE0 is going to support for user LED 4, and RE1 is going to help you for user LED 5. Got it? So this is how we have understood what are the different techniques or designs that we can think of for push buttons and deep switches as well as LEDs. Let us see more application in this particular circuit that we have implemented, because a lot of other pins are also available still. So next thing is, I have taken a plus minus 1 degree centigrade temperature sensor, which is associated with I2C or SM bus interface. Okay, so this is from Texas Instrument. The part number is LM73. Okay, so this LM73 part number, what is going to happen is, this is going to give you an alarm based on the temperature that it has sensed. Okay, so suppose you have set the temperature through your I square C interface, let's say 50 degrees centigrade. So once the 50, the temperature sensor reaches more than 50 degrees centigrade, it will give you alarm. Alarm in the sense, basically what it will do is, the alarm pin has been pulled high. Okay, so it is actually right now high. Now whenever the temperature reaches more than 50 degrees centigrade, okay, then what will happen? This will pull the pin to low, and this is how this alarm pin will indicate to the microcontroller port pin that your temperature has increased beyond the limit. Got it? So once it increases beyond the limit, whatever action if you want to take, you can take up. Like you want to switch off the system, or you want to let the system cool down for some time and again restart. So based on that, you can take a decision. So this is very good. Another pin is address pin. Okay, so address pin can be of three options. We can either keep it open, or keep it grounded, or keep it high to the voltage. Okay, so I have kept it high to the voltage with 10 kilo ohm pulled up. So this is one of the technique to keep the address 1. Okay, and this is also going to the microcontroller pin. So as I told you just now, let me go back and tell you, this is my alarm pin which is going to RC0, and this is my address pin which is going to RC1. Got it? So the complete design that is available here has been mapped accurately to the microcontroller pin, and you can directly take this particular schematic and keep your implementation ready. So this is temperature sensor with your alarm indication through your I2C as well as SM bus interface techniques. Let me give you another temperature sensor which is most widely used for very robust applications, and it can be utilized for your thermometer development, or normal temperature sensors for your home applications or automotive applications. This is very widely used, which is LM35. LM35. So I have taken TO92 package. This is a bit lower cost compared to CAN package. Okay, so you can see it has a value of like plus minus 0.5 degree centigrade or plus minus 1 degree centigrade if you take higher temperature range. This is the accuracy, and you can see temperature slope that will be 10 millivolt per degree centigrade. So each degree centigrade increase, there will be a 10 millivolt that will be available. Okay, so what is the thing that you have to do? You have to give 5-volt input to the VDD pin, that is supply pin, and V output you have to take through a filter I have given here. If you don't want to give a filter, then also it is fine, no problem. However, through this filter you will get your RE2, and RE2 is going to your ADC value, and this ADC value will give you the corresponding temperature that you want to find out. If you want to know the algorithm to identify what is the corresponding temperature based on the ADC value that has been read through RE2, like what will be the corresponding temperature, that I will be I can tell you out very easily through the data sheet table as well. Okay, so if you have any query regarding the algorithm, how to get the temperature, corresponding temperature, you can put your queries. From the data sheet I have collected some of the parts and this was actually from LM73. It is not for LM35. Okay, now another application that I have implemented here is buzzer. Okay, so any application you will be seeing, if there is an alarm or something, you want to give a beep sound. Okay, so to get the beep sound, I have put a magnetic buzzer transducer which is going to up to around 82 dB sound maximum, and this I have used a part number which is CST 951 AP. So 951 AP is actually 5-volt transducer, and 931 AP is actually 3.3 volt transducer. Okay, so since this microcontroller is working for at 5 volts, I have utilized 5-volt series. Okay, now what I will do is, this is around 2.7 kilohertz buzzer. So what I will do is, I will be putting a 50% duty cycle PWM here with 2.7 kilohertz frequency. So once you give this, then what will happen? This particular transistor will help this to switch on, switch off, and what I'm going to do is, this particular transducer is going to get connected to pin number 1 and pin number 2. If you want, you can directly give this particular buzzer at this J12 place. Okay, you don't have to give a separate connector for it. Okay, since I have not designed the particular symbol regarding the buzzer, so I have given a connector as a replacement there. Okay, but directly you can give this buzzer here at pin number 1 and pin number 2, and this is bipolar, so you don't have to worry about the pin numbering. You can directly give it at any pins. Got it? uh, in the application circuit, if you will see a diode that is connected across the pins, and it will be helping you to give a beep sound for the buzzer. I have given a resistor as a option which is not used. There are several other buzzers which are actually used with resistors instead of diodes. So it is very easy to design this schematic with diode as well as resistor both, so that you can utilize your any kind of buzzers. Got it? Good. So we have seen buzzers as well. Now let me show to you the ADC. So as you know, we have the 5-volt supply here in the microcontroller. So what I have done is, I have taken 30 kilo ohm and 20 kilo ohm. So it means it will be giving you 2 volt at this place. Okay. So I have simply taken a buffer here with LM358 series op amps, and I have taken filter, and I am going to go ahead with your RH0, which is your ADC pin. So that ADC value will read a particular voltage which will be 2 volt, and I will decide the voltage which was input as my 5 volt is actually correct. So suppose, let us say I am reading a ADC value which is coming up some count, on corresponding to that my analog value is reaching to, let us say some count is like 300 or 200 or 1000. Okay, corresponding to that my voltage is reaching to 1 volt. So what I will decide, my 1 volt is coming here, it means my input voltage is not correct. Got it? So this is how you can check your input voltage 5 volt based on the ADC value that has been read. Okay. And this is how you can decide whether to switch off the system itself because the input power supply is not correct. Got it? It's very easy to design. Similar way, I have taken another ADC value which will be going to RA2 and RA1 for another ADC value which is ADC0 and ADC3 that are actually coming from outside circuits and need to be like identify what is the value of ADC. Got it? If you want, you can keep a buffer for this particular microcontroller. If you don't want, even without buffer, just filter is enough. Okay, because this is very sturdy microcontroller. So you can just try out and see RA2 value will also give you the correct ADC value as well as RA1. But I will request you or I'll recommend you to give a buffer always whenever you are supplying your like analog voltage to the ADC pin of a microcontroller. Got it? So as I was talking about, like this is the external interface that I have taken, and this is my like power supply pin which is going to the external circuit. This is my ground pin which is going to the external circuit. This is enable pin that I have taken from microcontroller which is going to enable the external circuitry. Okay, so there is external circuit which is available, and I want to enable some of the circuit for that. So I can give a high or a low based on the requirement. Similarly, I am taking a on off signal from external circuit. Like let's say my external circuit is on, then it will indicate that yes, the circuit is on. So it will give me a high. Based on that, I will decide, okay, the circuit has been switched on. There are two ADC value that has to be like monitored, like ADC0 I have named it, and ADC3 just now I told you in the previous circuit. You can see this is ADC0 and this is ADC3. So both of these two values has to be monitored and checked out, like what is the thing. So if you want to, you can use this particular connector as like a Berg stick, which is the part number I have given you here, 61300611121, or you can utilize box connector also, which will be exact part number that I have given here. Okay. So hope you have understood the complete circuit design of this particular microcontroller that was there with us. Okay, and if you do have any questions or any like queries regarding this, then we'll talk more about it. Anyway, I have given more options here: UART RX, UART TX, and like SDN ISCL, that will be your I2C pins. Okay. So SDN SCL will tell you the I2C pins. Got it? Next is we have a same I2C and like I2C pin as SPI pin. Okay, so you can see we have SDI, that is SPI SDI, as well as SPI SCK, and you can see here SPI slave select pin. Okay, and you have SPI SDO pins. Okay, so these are the four pins that will be used. Let me color from different way. So this is your slave select pin for SPI, and this is going to be your SPI SCK, and this is going to be your SPI SDI pin, and this is your SDO pin SPI. Okay, so this is how you can utilize this particular microcontroller with your SPI communication. Same way, UART communication, UART RX and UART TX is also given. So I have taken a connector for this with pull-up resistors that I will show you quickly. Okay, so let me take you to the complete circuit that we have designed here. So hope you are able to see the complete circuit. So this is the UART that I have taken here, and this is the complete circuit that you can see. And if you do have any questions or any queries how to design the circuit in your like systems or in your softwares that you can think of, this is the buzzer that I have taken. This is the like ADC buffers and ADC pin reading that I have taken. This is temperature sensors with alarm that I have taken. This is the normal temperature sensors that I have taken. Here this is external like interface that I have taken. In the next tutorial, what I will do is I will take up some of the most important peripherals, which are like LCD, as well as I was telling you, and then we'll talk about data communication. Then we will talk about SPI, actual SPI communication, like how we will take up some application circuits, then UART application circuits, Even I2C application circuit we'll talk about, with EEPROMs, how we can interface EEPROM. So a lot of different circuits I'll talk about. Anyway, if you want to talk about all these peripherals, you can see a lot of videos I have already uploaded based on the microcontroller, which was MSP-M0L series. Okay, so MSP-M0L series schematic design tutorial, if you see, you have lot of different kinds of like applications that has been interfaced, and you can take reference from there. Okay, good. So, all right, guys, I hope you have understood the complete design techniques and how you can proceed for your circuit design for this particular microcontroller. And if you do have any queries still, like if you want to know how to assign a particular microcontroller pin for a specific task, and how we should manage our available resources, these all pins actually are called as resources that is available with you, and how you can optimally utilize them for your work or for your like project requirement, that is your like skill, that is your ability that is actually judged. Okay, so for any kind of queries like this, do put your questions in the comment box, or you can directly reach out to us on our email ID and the WhatsApp numbers that we have given to you, and it will be easier for us to address your questions. Okay. So, alright, guys, see you. Thank you so much. Just enjoy this particular circuit and learn as much as possible. If you have any questions, please reach out to us.